Ever since Apple started putting its insanely powerful M-series chips into the iPad Pro, the tech world has been living a lie. On paper, this wafer-thin tablet looks like an absolute monster. The benchmarks show scores that literally beat most premium Windows laptops and easily match Apple's own MacBook Pro. But there is a massive catch that the marketing materials never talk about. The iPad Pro has a dark secret. It is a sprinting machine, not a marathon runner. It can hit incredible speeds for a few minutes, but then it hits an invisible wall. That wall is heat. When you pack a massive amount of computing power into a chassis that is only about 0.2 inches thick, you run into a brutal law of physics. There is simply nowhere for the heat to go. The current iPad Pro models rely entirely on passive cooling. This means they do not have fans to push hot air out of the device. Instead, the heat just sits inside the aluminum body. It builds up second by second while you work. When the internal temperatures get too high, the system has to protect itself. It does this through a process called thermal throttling. The iPad purposely slows down its own brain just to keep from melting. This is the exact reason why the current iPad Pro cannot live up to its full potential. In real-world stress tests, the current M-series chip inside the iPad Pro runs noticeably slower than the exact same class of chip inside a MacBook Pro. We are talking about a performance drop of around 8 to 10% during long tasks. The silicon itself is not weaker. The architecture is identical. The only difference is the cooling space. The MacBook Pro has a thicker body and an active fan to blow heat away. The iPad Pro has to suffer in silence, sliding its performance backward to stay safe. But a massive shift is coming. New supply chain reports indicate that Apple is finally fixing the biggest weakness of its flagship tablet. The next generation iPad Pro will reportedly adopt a revolutionary cooling feature originally designed for the upcoming iPhone 17 Pro. This feature is a vapor chamber. If you're not familiar with hardware engineering, a vapor chamber might sound like a small detail. In reality, it changes absolutely everything for sustained performance. It is the missing link that could finally transform the iPad Pro from a powerful luxury media tablet into a true laptop replacement. To understand why this matters so much, you have to look at how a standard iPad spreads heat right now. Currently, the processor sits under the screen and transfers its heat to a small graphite sheet and the metal logo on the back. This creates an intense hot spot right where the chip lives. The rest of the tablet stays relatively cool while the center cooks. A vapor chamber completely eliminates these hot spots. It is a tiny, sealed metal structure filled with a microscopic amount of liquid. When the processor gets hot, that liquid turns into vapor and instantly rushes to the cooler edges of the chamber. Once it cools down, it turns back into liquid and flows back to the chip. This continuous cycle moves heat across a massive surface area at lightning speed. Instead of trapping the heat in one tiny zone, the entire back of the iPad becomes a highly efficient heat sink. The peak temperatures inside the chassis drop dramatically. Because the device stays cool, the processor does not need to throttle. It can hold its maximum clock speeds for an extended period. This means no more sudden slowdowns, no more dropped frames, and no more frustrating lag during long work sessions. Apple is planning to pair this advanced vapor chamber with its next-generation M6 processor. The M6 chip is expected to be built on an incredibly advanced 2-nanometer manufacturing process. Right now, the latest chips use a 3-nanometer process. Moving down to 2 nanometers means the transistors inside the chip are packed even closer together. This transition offers two massive benefits. It increases overall computing efficiency and significantly reduces power consumption. When a chip uses less energy to do the same amount of work, it naturally generates much less wasted heat. When you combine a highly efficient 2-nanometer chip with a high-performance vapor chamber, you get a perfect hardware synergy. The chip itself produces less heat, and the vapor chamber removes that heat at a much faster rate. This dual-layer upgrade targets the exact pain points that professional users have complained about for years. It allows the tablet to maintain high performance levels that match a dedicated notebook. Let us look at how this changes the game for actual day-to-day work. Think about mobile video editing. Right now, editing a short video on an iPad is a breeze. But if you try to export a long 4K project with multiple color grades, heavy text effects, and background noise reduction, things change. During the first 2 minutes of the export, the iPad flies. By minute 5, the chassis is burning hot to the touch and the render speed plummets. The export bar crawls forward. With the new M6 cooling setup, the iPad will hold its maximum rendering speed from the first second to the very last second. A render that used to take 20 minutes could cut down significantly because the chip never has to take a break to cool off. The exact same benefit applies to high-end mobile gaming. Desktop-class games have been pushing onto the tablet storefront for a while now. We have massive titles with beautiful graphics and ray tracing. The problem is that these games heavily stress the graphics processing unit. Within 15 or 20 minutes of playing a graphic-heavy game on the current iPad, the frame rate begins to stutter. The device gets uncomfortable to hold, and the screen might even dim itself automatically to save thermal headroom. A vapor chamber solves this entirely. It extracts the heat from the graphics chip, keeping your frame rates locked to their maximum settings for hours at a time. This thermal revolution also completely redefines mixed creative workflows. Think about batch processing hundreds of high-resolution raw photos, working on complex 3D models, or running live audio effects pipelines. These tasks put an intense simultaneous load on both the central processor and the graphics processor. This combined workload creates a massive thermal spike almost instantly. Passive cooling systems simply cannot keep up with mixed loads. The new vapor chamber design ensures that these heavy professional applications remain perfectly stable, smooth, and predictable. This creates a serious marketing dilemma for Apple. When a product is already incredibly fast and beautiful, consumers lose the incentive to upgrade. They look at their current tablet and realize it handles their daily tasks perfectly fine. A new compelling narrative is needed to convince professionals to invest in next-generation hardware. Cooling and sustained performance are the perfect answers to this problem. It allows a device to market itself on unlocking the true potential of the silicon you are paying for. Buyers no longer want a device that can only hit peak speeds for a quick benchmark test. They want a machine that stays fast throughout an entire workday. There is also a massive strategic angle at play here regarding software ecosystem dominance. Years have been spent aggressively pushing desktop-class workflows onto the tablet platform. Full versions of professional video editing software, complex logic applications, and advanced external display support have all been introduced. Incredibly high-quality keyboard cases with integrated trackpads have been built to make the tablet look and feel exactly like a laptop. But all of this software effort falls flat if the hardware cannot sustain the load. If a user connects their tablet to a high-resolution external monitor and tries to run a heavy production workflow, the thermal limitations immediately hold them back. A vapor chamber is the direct, definitive answer to this ecosystem bottleneck. Let us discuss the realistic launch timeline for this highly anticipated machine, because timing is everything when it comes to upgrading your tech gear. The current supply chain indicators point toward a release window in the first half of 2027. This timeline perfectly aligns with traditional update spacing for this premium device line, which typically operates on an 18 to 24-month cycle. This extensive development window gives the engineering teams the exact time needed to secure high-yield production for the new 2nm M6 chips. It also allows them to fully refine and stress test the new internal vapor chamber design to ensure it meets strict quality standards. This projected wait time is a crucial factor that should heavily frame your immediate buying decisions. If you are currently in desperate need of a new tablet for your daily workflow, waiting until 2027 makes very little sense. The current models available on the market right now are absolute performance monsters that will easily handle everyday browsing, media consumption, and light creative tasks without breaking a sweat. However, if your specific career or hobby involves pushing mobile hardware to its absolute limits with sustained heavy workloads, it would be incredibly smart to hold on to your cash and watch this upcoming development cycle very closely. Price is naturally the next big concern that everyone wants to break down. Early whispers from industry analysts suggest that the starting prices might actually remain relatively stable for this next generation. The primary reason for this pricing stability is the reuse of the external chassis design and the existing display technology. Massive amounts of capital do not have to be reinvested into completely retooling factories for a new physical shape or a new screen manufacturing process. Of course, implementing an advanced internal vapor chamber and buying cutting-edge 2nm wafers from silicon foundries is an incredibly expensive endeavor. However, balancing component costs across an entire product portfolio is something these manufacturers excel at. Even if the internal manufacturing costs rise slightly, keeping the baseline sticker price similar while jumping the standard memory up to 16 GB would represent an absolute massive leap in real-world value for the end consumer. Let us bring the focus back to the core headline claim that is generating all of this excitement across the industry. The next flagship tablet is getting an advanced vapor chamber cooling system directly adapted from upcoming premium smartphone development pipelines. That single piece of copper and liquid engineering is the missing link the ecosystem has desperately needed for nearly a decade. For years, the community has been waiting for the exact moment where the Pro tablet stops acting like an overpowered smartphone and starts performing like a professional workstation. We are waiting for the moment when a heavy workload can last for an hour or even an entire afternoon without the device flinching, dimming its screen, or dropping its processing speeds. In my honest opinion, this upcoming release might genuinely be the most important hardware change planned in years. For the longest time, the device has been trapped by its own beauty. It wanted to be a pro computer, but it was built like a thin phone. By adding a vapor chamber, the manufacturer isn't just tweaking the specs. They are unlocking the full potential of these monstrous chips for the first time in a tablet form factor. If you are a power user who has been burned by thermal throttling in the past, this device is going to be an absolute game changer and well worth the wait. It completely shifts the value proposition from a luxury media consumption device to a legitimate, uncompromised productivity powerhouse. If you like the video, subscribe, share the video, and hit the bell icon so you never miss another deep dive into the future of tech.